Hello, my name is Colin Lynch, and in this video we're going to be looking at doing a VMware NSX site failover. I've been doing a lot of work recently with VMware NSX, particularly around doing site failovers. So I thought it'd be nice to record a video that can be used for training purposes or for anyone who wants to do a site failover just to familiarize themselves with the process. It's never good to, the first time you do a site failover process being in actually a DR scenario, so it's always nice to have a bit of a reference and a bit of a good idea of what to expect. So what we're going to cover, we're going to look at the network topology that we're using for this site failover. So we'll go through the various elements and what each element does. We'll look at doing a planned versus unplanned NSX failover. As mentioned, you should run a failover test, at least as part of your initial build, and then maybe every so often just to make sure that everyone's familiar with the process and what to expect. And definitely know the impact, so know the impact of migrating certain NSX elements, what will work, what won't work until that element has been failed over, etc. Impacts to expect for the management plane, control plane and data plane. Prerequisites. So definitely if this was whether it's a planned or unplanned backup failover, it's always good to have backups. I mean, reliable though these appliances are, shutting them down and depending the circumstances on which you're recovering from, definitely good to have backups. And definitely ensure that in this scenario we're going to be using two sites, a site A and a site B. Our primary site being site A and secondary site B. Pre-create all the constructs you're likely to need in site B as part of your initial installation. Again, don't let an actual DR real life scenario be the time when you're having to remember, oh, I need an IP pool for my controllers in site B, I better create them. You'll need things like IP addresses, and as we all know in the real world, those IP addresses can take a little time to provision request from your ICMPs or your IPAMs, etc. Okay, and then we're actually going to look at the failover procedure itself. So we'll do a failover and a failback. So what my intention is that we'll go through this on the topology diagram in theory, and then we'll jump onto the kit and actually do a live NSX failover. So, okay, so this is the topology we're going to be using today. So as you can see there, we have our two sites, our site A and site B. The main elements we're going to be interested in is obviously our NSX managers. So we have our primary NSX manager in site A, our secondary NSX manager in site B, our universal control cluster that is deployed at the same site as our primary NSX manager, so in this case site A. Other elements involved is our NSX edges here. Now these are equal cost multipathing edges, ECMP edges. So they are tied to the site. They're not failed over as part of the process. So think of those just as a site specific router, or routers in this case. We also then have our distributed logical router, our UDLR. Now that being a universal object, stretches across both sites, so is under the jurisdiction and control of the primary NSX manager, but certainly can be seen and utilized by the secondary NSX manager in site B. Now that universal logical router has a control VM. That control VM essentially is a VM that handles all the dynamic layer 3 adjacency. So that would actually have your layer 3 dynamic routing adjacency, or OSPF or BGP as it is in this case, adjacency with your tier 0 edges up there. That DLR control VM definitely needs to move across, because as you can see, without it there would be no layer 3 adjacency, and your actual workspace logical switch prefixes will not be advertised out, because obviously they're relying on a dynamic routing protocol there. There's lots of different scenarios into how your NSX environment could be deployed. In this topology here, we're not using local egress. Local egress is a cross-site strategy where you actually have a control VM simultaneously at both sites. So you'd have an additional transit switch in the middle there, one for your site A, one for your site B. So your control VM would actually be both sites simultaneously, and your control VM would only actually peer with the edge routers at the local site. However, in this case, the customer requirements here is that most of their workloads were in site A, but they also wanted to utilize their WAN links in site B, but they wouldn't necessarily have lots of live workloads in site B in a non-failover scenario. So the design decision there was to implement what's called mirrored ESGs, where you actually have a single control VM, but it's peering across one transit switch, universal transit switch, to both sides. So again, when we jump on the kit and we have a look at the BGP neighbors of this control VM, we'll see it's actually peering to site A and site B simultaneously. Okay, so I think that's a good overview of the kit, and obviously we've got our vCenters and our primary service controllers. Again, they don't move, they'll be tied to the site. And there's one thing that's worth mentioning there is also, again, we've got a services ESG in our logical switches. In this case, it's a edge load balancer, and again, that's not a universal object, so that is tied to the site. So we'll need a strategy of moving those services from site A to site B. Again, numerous ways of doing that. You can either do some sort of dynamic REST call to create that object as part of your failover plan over in site B, but probably the most simplest is to just recreate an identical load balancer, identical IP addresses in site B, and just turn it off until your DR is required. So that's the strategy we'll be using in this video. So again, there's lots of more intelligent ways you can do a NSX failover. You can implement, or you can use tools like VRO with workflows. There is actually some custom workflow objects for VRO that will assist in doing a cross-site NSX failover called the NSX Cross-Site Extensibility package. So again, I'll look to probably cover that in a future blog post. But when all said and done, you need to really know the good old manual method before you look to automate any of this stuff. Because if any of that stuff is unavailable or breaks during a failover scenario, at the end of the day, you're going to probably have to roll your sleeves up and do some of this manually. Anyway, so always good to know the manual process as your baseline benchmark. Okay, so the high-level procedure, and again we'll step through all these in detail. So the failover procedure is, now again, depending on whether this is a planned or unplanned failover, you may not even have access to your primary site. Worst case scenario is the whole site's offline. You can't get to it to gracefully shut anything down. In this instance, we can shut things down. But again, this doesn't really matter either way. I'm only going to shut down the elements in site A just so we can 100% be sure that we're not actually using any of them. We'll then go to our site B and we'll disconnect our secondary NSX Manager from our primary to break that association, which will put that NSX Manager into a role called Transit, and then we'll bump that fella up to a primary role. And then we'll deploy our new universal control cluster, and then deploy our new UDLR control VM. So again, I've mentioned we're not using local egress, so I'll have to facilitate moving that fella across. And then we'll power up our load balancer edges or our edge in this case, in site B. So again, that's the standalone edge that's providing some load balancing services. And then we'll do some successful failover testing. We'll have a look at the management plane, control plane, and data planes just to make sure we're all back and we're running where we should be. And then the failback procedure is pretty much the reverse. So we're going to power down our service edges in Site B. We'll power up all our components in Site A, so our NSX Manager, our Universal Control Cluster, our UDLR Control VM, and our load balancer in Site A. And then we're going to do our cleanup in Site B, so we'll delete the controller cluster over there, remove the NSX primary role from the NSX Manager in Site B, and then we'll remove the secondary NSX Manager association from our original primary, and then we can reassociate our secondary NSX Manager in Site B back to Site A again. And then we'll do a little bit of a cleanup. We will also have to delete the control VM over in Site B, and currently we'll need to do a REST call for that. But again, we'll get to that bit when we're actually doing the actual failover. So again, just to look at this on a diagram to cover the steps we're going to go through. So under normal conditions, this is how our network looks. So we have our two sites, our NSX Manager Site A, NSX Manager in Site B, our Universal Control Cluster, so we've got three VMs, and our UDLR Control VM, and then obviously our load balancer. So again, a rough overview of what these elements do. So NSX Manager is obviously our management plane. That's where we do all our GUI, our REST calls, etc. Our control cluster is essentially the control plane of the network, which will learn routes from elements like the UDLR control VM and then program those routes into the hosts. So again, without that control cluster over in your Site B, your hosts routing tables are not going to be updated. And our ESG load balancer down the bottom there. So I'm currently running that fella in active standby. So essentially we should be pretty fault tolerant within a site, but I say worst case scenario, and we actually have to move sites, we can move these elements across. And obviously the whole point of this is to maintain connectivity with our workloads. So again, we've got a workload over in Site B, and we've got our workloads in Site A, but again we're going to assume that that whole Site A has gone down. So while this video will cover the NSX elements of the failover, obviously you do need to have provision for moving all your VMs over. Whether that's using a tool like Site Recovery Manager or SRM, or whatever your tool of choice is. Obviously, the whole point of this is to get some workloads up and running in Site B. Again, a good valid design might be that these two data centers are active, where you have active workloads in Site B anyway. Okay. So let's assume that our Site A goes offline. So the first thing we're going to do is promote our secondary NSX Manager to primary. So the way we do that is we just disassociate it from its primary. That will put that NSX Manager into a transit role. We can then assign the primary role to it, and then as I mentioned, that once it is a primary NSX Manager, it can then edit and control universal objects. And that's one thing I guess to bear in mind, is that the primary and secondary roles only relate to universal objects, while that's the secondary NSX Manager. It obviously is also fully in control of its local non-universal objects, so things like these ESGs here and what will be our load balancer. So again, that's now our primary NSX Manager. We're then going to deploy our new controller cluster, our new universal controller cluster in Site B, essentially moving our control plane over. Then we will redeploy our universal control VM. So again, that's the element there, that VM that handles our layer 3 adjacency with our edge router here. So we then should see our routes reappear in our Site B Edge Service Gateway, or ESG. and then we're going to turn on our pre-prepared, in the old here's one I prepared earlier, our ESG. So again, probably more intelligent ways you can pre-provision that ESG over there. The simplest way, as I've mentioned before, is just to pre-create it and turn it off. Pros and cons with everything. Generally the arguments are, well, if I pre-create it over here and I turn it off, and then this config changes over here, I've got to then remember to update the config over there, and that's true. So there is a risk of config drift. But essentially, what are the other options there? You could, as part of your SRM recovery plan, have a nice REST call that creates that dynamically as part of your failover scenario. But then again, you've got the same issue, is that REST call, where is that coming from? Because again, in a DR scenario, you can't assume that this primary NSX Manager is going to be available for you to do that get from. So in which case, you'll have to have that full config, that REST call stored somewhere, ready to do a post down to the Site B NSX Manager. And then you've got the same potential issue of config drift. So if you've got that get stored somewhere, ready for a post, and then this load balancer changes, so you've now not only got to make your change here, but you've also now got to remember to change that REST call to add that VIP in, or whatever those changes were, and that's a different process. So getting an admin to make a change here is pretty straightforward, but then saying you need to go and change that XML file for that REST call as well, again, it's a different process. Whereas it's probably a little more simpler, just say, you know what, the change you made there, as part of the process, make it over there as well. So that again, you just have to processize, if that's a word, that task. Okay. So once we've done that, our Site B or our Site A is then restored, and then we have a fail back to do. So currently we're now running our full environment over in Site B. So first thing we'll do is delete our universal control cluster in Site B. Well, essentially the first thing we'll do, actually, we'll turn everything on in Site A. So then we'll delete our control cluster. Then we'll delete our control VM. And again, that's a REST call currently, as we'll see when we get to the actual walkthrough. We're going to revert our Site B NSX Manager to secondary. So again, we'll just remove that primary role, put it into transit, and then we'll add it back to Site A as a secondary. Obviously, we'll power off our load balancer, because obviously that has the same IP as the load balancer over there, so we don't want those IPs to clash and that VIP to clash. And that will be essentially our failback. So I've left a link here to the a document called the Cross-VC NSX Design Guide. Now, in that design guide is a sort of full breakdown of this process. So again, definitely always read the documentation. Things may change as versions increase. The version of the lab we're using here is NSX 6.4, but it's pretty much the same process with all the 6 releases. But again, always double check, always read the docs for the version of NSX you're running. Okay, so I think we've sort of laid the foundation of what we're going to do there. So let's get on and actually do the failover. Right, so let's have a quick walkthrough with our environment. So as you saw in the topology diagram, we've got 2 sites. So this is our vCenter A, which is running enhanced link mode to vCenter B. So at the moment everything is in a healthy running state. So you see I've got 3 clusters over in Site A, our management cluster, which has got our 3 universal controllers, our NSX Manager for Site A, our Platform Services Controller for Site A, and our VCSA, our vCenter for Site A. Also got a few VMs over there, Active Directory, Jumpbox, etc. Then I've also got a prepped NSX cluster, which is for workloads and edges. So you can see we've got a few edges, a DLR, a universal DLR, which is the main one we'll be using today, a ESG, which is our tier 1 north-south router. That's actually running in HA mode. Normally you'd run those in multiples with ECMP enabled. I've got a load balancer providing web front end. That's actually load balancing to 2 web servers, one of which is site A, one of which is site B. That's one of them down there. The other one is in site B, which we can have a look at now. So here is our site B, just the one cluster over in site B with a couple of hosts in it, which are NSX prepped. So over there we have our north-south ESG, our NSX Manager for site B, our Platform Services Controller and vCenter for site B, and then we've got the other web server over there, the web server in site B. And again, that's the one that load balancer there is providing a VIP for. And if we want to give a quick test of that, I can just fire up a web page to it. Site A web server. So again, if I just refresh that a few times, you should see it flip between site A and site B. Okay. I've also over here got a SolarWinds ICMP tracker. If I can get it to pop out over this RDP session. There we go. So you can see obviously everything with the green light is responding and reachable, which is pretty much everything apart from our 3 controllers in site B, because they do not exist yet. So you'll be able to see as and when things go offline, as and when things come back online. So you'll see those red, green dots go red and red dots go green, etc. So we'll check in on that from time to time. Okay, so we're just going to check. So again, we're going to simulate a whole site failure here. So we're going to pretty much turn off all our NSX components in site A and then recover the site in site B. So let's just have a quick walk around the environment. So again, we can probably assume that site A is not even reachable. So I can flip across to the other vCenter in site B. Because they're running enhanced link mode, I'll see pretty much an identical scenario. So my site A and my site B. So it doesn't really matter which side I do this from, but again we're going to assume that site A is offline, so we'll do it all from site B. Let's have a quick check in with our NSX Manager. It's always worth having an eye on the dashboards. So again, this is NSX 6.4, which is currently the latest release of NSX-V. Okay, so we've got all our controllers are up, our external edges and such like are up. I'm getting a warning for our NSX Manager UI with a synchronization issue. Okay, we shall address that. Okay, so there's our primary, which is in site A currently. And I've got a little bit of a lag over the VPN, but hopefully this should show me a secondary in site B, which it does. So again, if I was to refer back to our diagram, that's it pretty much in graphical format. So you can see our site A, our site B, Our platform service controllers vCenter pairs there, so you can see our synchronization is between our NSX managers. In fact, I'm not sure. In fact, okay, so there we go. So there's our diagram. So you can see there we've got our two NSX managers, one in site A, one in site B, our platform service controllers and vCenter pairings. And you can see there that currently our NSX manager in site A is primary, which has the universal synchronization service enabled, which is synchronizing over to site B, which in turn sends those universal objects to vCenter, which is how they get to the other site. We have our single universal control cluster in site A, so that's currently programming all the hosts on both sites. There's our northwest ESGs. So again, I've got one over here which is actually an HA pair, but again normally you'd have those in multiples of ECMP to get a bit of additional fault tolerance and bandwidth. I've only got the one over there, but again you'd normally have probably a couple each side at least. There the edges actually peer to our top of rack, our real world, our proper VLANs. So we generally turn those as a tier 0 where physical meets virtual. Then we have our universal logical router down here, and again, as mentioned in the intro, we only have a single UDLR control VM at one site, peered to both sites, so we're not using local egress where you'd have one on either site. Mainly reason because the customer are actually doing a lot of failover testing and proof of concepts is using this exact model. They had a requirement which lent itself more to a mirrored ESG approach rather than local egress, so this is why I've got this environment set up here to purely reflect their environment, but also is also quite nice for this video because it shows you an additional step that you wouldn't necessarily get to see if you was using local egress. For example, if you was using local egress with a control VM in site B, you wouldn't see the process of how to move that. So if you are using local egress, you can just forget the UDLR control VM deployment. And then there's our load balancer down there. So that's a VIP, which is .100, and that's load balancing to a couple of VMs, one in site A, one in site B, which we've just had a look at. So again, that load balancer is live in site A, which we're about to fail, and then we have an identical of it configuration wise with the same VIP, same IP address, same everything, but powered off, so ready to be powered back on in event of a DR. Right, so I think that covers sort of a comparison with the diagram to the live environment. Can have a quick look at our secondary NSX environment. Let's just try and rectify that quickly. Okay, that looks happy now. I think it's probably because I replaced all the certificates on these earlier. Right, so everything is now happy. So again, you can just also confirm here that your backups were successful. You can also go to the actual NSX Manager UI itself and have a look at your backups. But in this dashboard, it gives you a nice little summary. So again, let's have a look at our Universal Control VM. So as you can see here, we should have a BGP peering with both our sites, which is .2 and .4 in this case. So let's just go and confirm that's all happy. Again, these are the similar sort of tests that we would do when we fail back, just to make sure our control and data planes are all restored. Don't need that fella. Okay, so that is our UDLR. Just wait for my CLI to catch up. Got a little bit of a lag. There we go. So we should see 2 and 4 established up. So that's 2 and 4 established up. So our cross-site BGP peering is okay. And we can see that we're learning routes. Okay, yep, so I'm learning a BGP default route currently from .2. I've got a BGP weighting that prefers .2 over .4, but if .2 ever went away, the higher BGP weighting would kick in within 3 seconds, which I've got my timer set for to fail over to the other site. Right. Okay, anything else worth checking while we're here? I think we're about ready. So let us fail site A. So currently this is where my primary load balancer is. So at the moment that is happy, and that will flip between sites. But as soon as we turn off that load balancing edge, we'll lose connectivity, as we would in a proper DR site failure. So again, let's assume site A is offline. So let's all do this all via site B. So let's start failing some bits. So let's turn off all our NSX controllers, which is essentially our centralized control plane. So while these are down, the hosts will no longer be able to be reprogrammed by the controllers. So for example, our hosts will currently have routes via both data centers. So until this control cluster is redeployed over in the other site, the actual host will not be reprogrammed. Oh, so I can leave that power off. Okay, so we should see some of these start going yellow then red. Okay, let's also power off our NSX Manager. Let's also power off our UDLR control VM, which will in effect bring down our adjacencies to both of the edges in both sites. Don't really need to worry about bringing down our edges because the UDLR is in the middle of them, so that's killed any connectivity. We'll also just power off our load balancer, which will kill our VIP, which is our .100, which is this address here. So let's get rid of that. Power off. Okay, so I mean we could also shut down our PSCs and our vCenters, but we're not really going to be using them anyway. Okay, nothing else we really need to power off there that we're going to be playing around with. So that essentially is our site A down from an NSX perspective. So as we can see there, lots of red circles, so all our controllers are down, our NSX Manager, our DLR control VM, our UDLR control VM, our web server, VIP on our load balancer. So again, if I go back to my load balancer now and do a refresh, it's just going to sit there and time out. Our NSX Manager A is actually down now, so that's not even accessible. So right, so let's go and recover this site. So again, working from our site B vCenter. So let's go and have a look at what our NSX environment's looking like now. Probably a little less than healthy. Oh, what I shall do as well is I'm going to start this timer off down here, so you can see how long the failback roughly takes. If there's any sort of quite boring elements like the deploying of the controllers, which might take up to sort of 10 minutes, so rather than waste your time looking at a deploying bar, I might just speed up the video, but I'll leave this timer down here so you can see in real time how long each of these steps is likely to take. So it'll give you a very good idea of if you ever need to do this, how long to provision for maintenance windows or failover testing. So as you can see there, our NSX Manager in Site B is still active and healthy. Our 3 controllers are now unreachable, and chances are if I drop down here, yeah, so I can't see my primary anymore, and if I logged out and looked back in again, I'd see an error. So like, you know, cannot contact NSX NSX Manager. Okay, so let's start this recovery process. So the first thing we need to do is to disconnect our secondary in our site B from our primary. So our primary is unreachable, but that won't matter. Okay, so we can see there we've got an unknown NSX Manager, which was our primary, which is now unavailable. So what we want to do is disconnect our secondary from what was our primary. Again, this is going to be timing out on these controllers, so it will just take a few minutes. So disconnect from primary NSX Manager. Yes, we do. That should force that into a transit state. Okay, so now into our transit state. So now I can assign the primary role to this transit NSX Manager. Now once it's a primary role, as I'm sure you're aware, primary and secondary really only has relevance to universal objects, i.e. objects which span both NSX managers. With regard to local NSX objects, both in effect are active for their local sites. So again, that primary and secondary is only in relation to universal objects. So only the primary NSX manager can create or edit universal NSX constructs. If you try and edit it on a secondary, anything that requires read, write activities will be grayed out. I probably should have showed you that just before we promoted this fella. And again, the universal control cluster will always follow the primary NSX manager. So again, the secondary does not have its own controllers. They use the universal control cluster in the primary site. Okay, so we're now primary on our site B. So as you can see there, we still have no controllers. So first thing we're going to do is deploy our 3 controllers back again in site B. Now if you remember way back in the introduction, I said make sure all of your constructs that you're going to need for the failover are pre-created in site B. So for example, our IP pool for our controllers, make sure you create that well ahead of time. So you can see there I've got a pool called controller site B, and again this isn't the time you want to be thinking about creating this on the fly, having to allocate 3 IP addresses, having to go to your IPAM, like info blocks for example, and so trying to allocate IP addresses in a large data center on the fly is potentially going to be fraught with issues and potentially very time consuming. Again, in a DR scenario, it's not the time to be doing that, so you want to make sure all these are created pretty much when you deploy site A. So you think ahead of time as to all the constructs you'll need in site B, which will generally be an IP pool for your controllers, and make sure you know which distributed port group on your distributed virtual switch you're going to put your controllers in. Right, so that said, let's pop back to our installation and deploy our controllers. Okay, and now this is primary. We should see our little green plus sign spring to life, whereas previously it would have been grayed out. Just to wait for that to time out. Okay, so now we can begin deploying our first controller. So again, I will normally prefix these with the site B prefix, just because, so when we're deleting them a bit later on, and we might see all the controllers from the original site, that we'll know exactly which one we need to delete. So I'll call this generally controller site B, controller 1. NSX Manager is now going to be our one in our site B. Now we have to specify site B constructs for these controllers, so again know where you're going to put them. So again I'd have a pre-designed spreadsheet showing you in a DR invocation where these are going to live. Again, what I'll do is I'll attach in the notes to this video and on the blog post I'll show you an example of the Failover Runbook that I've written for this particular video, which will cover all these spreadsheets, which you can just alter for your own requirements. I don't think I've got any NSX controller folder in Type B, so we'll just leave it blank. So this is my pre-created Site B controller pool, which is actually those 3 IP addresses at the bottom there, so we should see those spring into life as soon as these controllers begin deploying. So again, I'm just putting a password in there. Now if you're intending running in Site B for any extended period of time, you'd probably want to use the same password there as your controllers in Site A, just for routine maintenance or any monitoring that you've got going on. Okay, so I need to make that a little stronger. As soon as that catches up. Okay, that should be our first controller deploying in our Site B. While that's deploying, what we could probably do is just check in on our edge over here, because at the moment there'll be no universal control VM for it to peer to. So okay, this is going to take a few minutes to deploy. Unfortunately, you cannot deploy controllers simultaneously. You have to do it sequentially, so we'll have to wait till that finishes before we can kick off controllers 2 and then controller 3. So currently, if we have a look at our north-south edge down here, so either you can just jump to the edge directly as I'm about to do here, or you can use your central CLI, either through the NSX Manager CLI, or you can do a central CLI API call. Because bear in mind you don't get cut and paste functionality if you're on the console, but luckily my passwords are pretty easy to type in. So if I do a show IP BGP neighbors, so you can see our BGP connection northbound to our top of rack switches is up, which is that 140.240 address, but our BGP adjacency to our UDLR control VM, which our protocol address there is 0.3, is connect up, which is actually, as we know, down. So it needs to say established. So that's not going to come back up until our UDLR control VM is back over this site. So again, one reason to use local egress is that you will not lose that connectivity in a DR scenario. Okay, so we'll check back in on that window as and when we get a little further down this procedure. Let's see how our controller's doing. Okay, still not quite there yet. And generally what I'll do is, if I'm doing this for either a live DR failover or a planned DR test, I'll also keep either a nice little notepad of all the timings as to what I kicked off when, just because it gives you a nice idea of if you're refining your plans or if you're writing runbooks for other people to follow. It gives them a good idea of how long to expect certain activities to take. And generally the first page of that runbook, it would be your prerequisites. So what passwords you would need to retrieve from any password safes. For example, the admin passwords to your NSX managers, the admin passwords to your NSX controllers, potentially your BGP passwords, and anything like that. So again, just check the notes and I'll attach a example runbook. Okay, so you can see here we're 14 minutes into our recovery, and bearing in mind that regardless of the scale of the site, you'll always only have 3 controllers, generally one NSX manager per environment. So you may have a management environment, a resource and compute environment. So if you've got multiple NSX instances, obviously you'll need to follow this procedure for each of those instances. Okay, so hopefully our NSX controller 1 should be nearing completion by now. Always takes longer when you're watching it though, doesn't it? What do they say? A watched kettle never boils. So as soon as that comes online, which will be 166, we should see whichever one of these little watch it circles is. So it'll probably be that top one out of those 3 dots. Oh, there you go. In fact, there you go. It's gone green, so this should be imminently with us. Okay, so now let's do our controller 2. So again, I'd call this site B. Controller 2. NSX Manager to pop in. Okay. Okay, so that's our second controller kicked off. So that's at about 18.5 minutes. So again, with a prudently designed network, if you've got a dual sites, potentially with dual site load balancers and local egress enabled, there's no reason at this stage you should have sustained any loss to your data plane. But again, without local egress here, with our single control VM, certainly those northbound routes for all our logical switches will currently not be being advertised northbound out of site B. So this will probably be our second little red dot down the bottom there. Okay, so that's been deploying for 3 minutes. So again, there's no reason I couldn't jump across and deploy the universal control VM now while these controllers are deploying, but so rather than confuse things, we'll do things nicely in series and in order, which is probably how I'd suggest you do it in a real DR scenario. Just follow the procedures. And again, once then you're fully familiar with the manual process, you can look to get a bit funky, bit intelligent, bit clever with it. Maybe combine it with an SRM recovery plan. Again, maybe utilize VRO or as I think I mentioned in the introduction, the NSX Cross-Site Extensibility package, which has a lot of predefined VRO workflows which will do a lot of these tasks for you. But again, as mentioned, it's great having all that automation, but you really need to know what's happening under the covers, just in case, for whatever reason, your automation workflows don't behave as you'd expect. So that might be a nice follow-up video to this one. So once we've got our manual benchmark, maybe we'll look at doing something a bit more automated, maybe using the Power NSX or VRO workflows. Right, oh, there's our green dot has come up, so means our controller is up, so it just needs to finalize. So while additional controllers are coming up, you will probably see the existing controllers go disconnected because they will be forming a new cluster between the controllers. So you'll see them go disconnected for a short while as they're exchanging certificates and such like. But a quick refresh should have them all green. Okay, so that was kicked off at about 18.5, so about 6 minutes to deploy that controller. So let's do our last one. Site B controller 3. Okay, we'll leave the host blank, which means we'll just leave the cluster to determine where it puts the controller. You're probably aware the controllers should be separated on different hosts. There's no automatic anti-affinity rule for controllers, so that's something you would need to create to separate them off. There is an automatic anti-affinity rule created for HA edges and DLRs, but not for controllers. Okay, that's connect it there, and this will be our last IP address of our pool. Okay, that should be our last controller. Again, probably take 5 minutes or so. Again, we'll know when this last controller comes up when we see our bottom red dot go green. So you can see there I've called these all Site B controller 1, controller 2, controller 3. You'll see an arbitrary controller name that the NSX Manager gives the controller. That name is not within your control there, so I wouldn't really worry too much about that one. So that's this name that you control. One thing maybe worth pointing out as well is that even though you see your bespoke name there, the controller itself will have a quite generic host name if you was to SSH into it, which you can, and it would be that generic host name you would see in things like VRLI or any syslog server. But again, you can just change that to match that name with I think it's something like a set system name or set host name. So then you'll see the proper name appear in your syslog server. Just a little tidbit while it's deploying to keep you amused. So you can see here our three controllers are all under the jurisdiction and administration of our primary NSX Manager. As and when we come to add a secondary in, you'd see those three controllers be duplicated in what I call shadow controllers, which aren't really controllers, they're literally just markers back to these three controllers, and they're designated to control the secondary NSX Manager or program the host in the secondary site. But essentially they're the same controllers. In this failover here, I'm not actually going to bring our previously active or primary NSX Manager back to life and add it back in as a secondary, although obviously you could do that. If this was going to be, what's a good scenario? So for example, you've done your site failover, a day later your secondary site comes, your old primary site comes back to life for whatever reason, but you would like, you don't want to do your fail back for a period of time, maybe a week, until you can plan the fail back gracefully. So what you may want to do in that instance is bring your old primary back to life, remove the old secondary from it, demote it to transit, and add that back as a secondary to your now primary NSX Manager in your site B. That way you can still have workloads in your old site A working and data forwarding as they were before. It would just be that your management and central control plane would now be located in site B. So I hope that makes sense. In effect, you'll be re-establishing your DR capability. Obviously, if you had failed over to site B, promoted everything, but then you did not recover your site in site A, you're now in effect running without DR. So again, if you're going to be doing this for any length of time, always, if you can, bring back your old site and add it as a secondary site. Just so your universal synchronization is now going back the other way. So if you was to make changes to universal objects, maybe add UDLRs or reconfigure universal logical switches, for example, or UDLRs, that change would be maintained and propagated back to the NSX Manager at the site A. Hope that makes sense. If not, just add me a comment, tell me I babble too much, or say that I say too much, which I do. Sometimes when I don't often edit these videos back, but as and when I do a bit of editing, I do cringe at the amount of time I say In fact, I think next time I do a watch back, I'll donate £1 to a charity for each time I say I'm not sure how much I owe the charity already for this video, but I'll have a tot up at the end and find a local good cause. Okay, so we're now at 32 minutes. I could forward the video, or I could tell you a joke. Okay, so our bottom red dot has turned to green, which means we're imminently expecting our third controllers come online. So again, don't be surprised if we see all of those controllers go disconnected for a short while they reform their cluster. Okay, so there we go, 3 controllers back connected. So next thing to do is redeploy our UDLR control VM. Let's have a little check-in with our ESG, our north-south router. So at the moment this still will have no adjacency southbound to our UDLR, which in this case is our 0.3, our protocol address. So again, active up, which is not up, very confusingly. So yeah, we need to say that, it needs to say established. Right, so in order to do that we need to create a construct for it to peer with, which is our UDLR control VM. So now this is our primary NSX Manager. We should be able to edit universal objects. So let's go back to our edges and have a look at our UDLR. So in this management environment we have a single UDLR. Chances are you will have numerous, so you'll obviously need to repeat this process for each of your UDLRs. So you'll see there it says active rather than deployed, which basically means it's got no appliance, no VM associated to it. So if I was to have a look in my hosts and clusters, or VMs and templates, whichever, I will not see a UDLR control VM. So this is our cluster down here. So if we can see our one controller, I'm sure that's probably just needs a little refresh. Yep, so there's our 3 controllers, but you'll see there is no UDLR, so there's nothing for our edge to peer with. So again, the UDLR control VM is not in the data plane, it's just a logical construct for those layer 3 adjacencies, and obviously to tell the controllers what routes are being learned, and then the controllers can subsequently reprogram the hosts with those routes. So we need to go and create that. You can see the old UDLR control VM up there, which is currently up there and turned off, so in effect we need to recreate that down here. So let's go back into our network and security, into our edges, okay, there is our UDLR. We are now primary, so we can edit this construct. So let's have a look at our configuration. If we go down to our appliance section, so the configuration is all here, but it's obviously just not applied. It hasn't created that control VM. So again, this is the step you would not need to take if you was using local egress and you already had your control VMs located in site B. For the sake of this exercise, we need to move it across. So you see there is no logical router appliances deployed, so we need to deploy one. So again, be familiar with what variables are going to be required in this section, add them to your runbook, again, in an outage situation, is not the time to be running around trying to find details of where to put things. So chances are this will be your Site B edge cluster. So let's put it in that nice big data store there. Again, we'll let the cluster decide where. Okay, so that is now redeploying our router appliance. So if I was to pop back to our edges, we should see that busy being deployed, and we do. This doesn't take too long. So we should probably see here, there you go, deploy our template. Gets that lovely user-friendly hexadecimal name that all UDLRs get. Okay, so that is deployed. So again, we should see that move to a deployed state. So again, one of these is the UDLR control VM, which is that middle green dot, that middle red dot out of those three there. So again, we should see that come online. As soon as that comes online, that will be the IP address that our north-south ESGs are expecting to peer to. So if the NSX gods are with us, that should automatically peer back. Let's have a little check in on it. Okay, so 0.3 is established up. So now all our logical switches that are connected to the lifts of that UDLR will now be advertised northbound. So our connectivity will be restored to any workloads we had in Site B. One thing to note, as I've mentioned, this is NSX version 6.4. When I did this for a live environment for a client that was running 6.3.2, a little quirk, whether it's a little bug or a quirk, I'm not quite sure. When I redeployed this, the BGP password did not come across with it. So what I needed to do there is just to went in there, went into my routing, found my neighbours, just edit your neighbour and paste your BGP password in there. In this environment I'm not using any BGP passwords, but I say just bear that in mind, that sometimes if you're using a previous version of NSX, you may find that those BGP passwords do not get maintained in this deployment. So if your adjacency doesn't come up established, that's the first thing I would check for. Check you can ping, and then if you can ping between your protocol address and your upstream ESG, check your passwords. Another thing to note is that, again, I've seen, let's just see if this is the case here, that sometimes the admin password does not come back with your newly deployed UDLR. And if that's the case, you'll just do a right click. As soon as my GUI catches up, change CLI credentials, same place you turn on SSH, and you just re-put your password in there. I'll just do a quick check just to see if our password has been maintained. So again, last time I checked in on Site B, we did not have a universal control VM. Let me just do a refresh here, because we should see one now. Yep, and there it is. So it's powered on. Let's just do a console connection to it. I think SSH is turned on, but Let's just see if our password was maintained. No. So I'd need to reset the password on that, which I can quickly do now. And that's something I have also noticed with redeploying the UDLR control VM via a REST call, that the CLI credentials do get, if you do a RESTful GET from an appliance or an edge from an NSX Manager and then change that to a POST, the admin credentials do not get copied across. I guess it's for security reasons, so you do need just to add in a section for CLI settings before you post it back, or just do what I'm about to do and subsequently just change the credentials. Okay, let's see if that's giving us access back to our UDLR. Again, you could always use central CLI for this, which wouldn't need the password, just your NSX Manager password. Right, let's have a look. Okay, so we're back in. Okay, we're all established up. That's .4, which is our ESG and Site B. Just finish that command first. Okay, there's my BGP routes being learned from my northbound ESG. So we are good. Okay, so we are getting there. So that is now our NSX Manager promoted. Our Universal Control Cluster is now moved over there. Our UDLR Control VM is now moved over there, which is now paired with my .4. So my north-south routing is now re-established. So the last but not least is to power on my, here's one I prepared earlier, ESG with my load balancing VIP over here. So let's do that, because currently my web server is still down. Okay, so let's go and power that back up. So that's my folder there. So this is one again I've pre-deployed and just turned off. So again, this isn't something you want to be trying to recreate on the fly in an outage situation. You want to do as much pre-work as you can. So it just means that if you ever make any edits to the live load balancer in site A, just remember to also do them in site B, but don't turn it on because they will obviously get a conflict. You could put a dummy IP address in it, just in case it gets turned on, but just remember to change the IP address in your failover documentation. Okay, so my VIP is now back online. Let's see if my web server is now reachable. Not quite yet. It's probably just going to take a sec. So again, that load balancer is just a standalone ESG running stateful services. And as it's running stateful services, in this case a firewall and a load balancer, you cannot run it in ECMP mode, just to prevent any asynchronous issues. You don't want to go in one ESG as a firewall, try and come back through another one because your state is not going to be there. Okay, so that should be why is that powered off? Okay, also wasn't off, just needed a refresh. Okay, so still not back. Let's just do a quick check on this fella. So it hasn't been on for a while, so it may not have quite the correct config on it. Let's just do a quick check. So it's now our load balancer in our primary site. There you go, load balancer B. Let's go and have a look. So the VIP is 100. So the VIP is on there. So let's just push this config down again to this load balancer. That basically just pushes the config down and gives it a reboot. Okay, let's just give that another sec. Okay, so let's refresh that. So that now all this refreshing is only going to be site B, obviously, because that's obviously the only one that's up. Okay, so our service is restored. Let's just double check our data plane. This is our northbound ESG. Okay, so our northbound is established, our southbound is established. Okay. And we're learning our BGP routes. Okay. So I think that is us fully failed over to Site B. So all of our Site B are now green. Let's have a quick refresh on NSX. Okay, so there we are, our primary in Site B, our old primary in Site A is still unknown. Right, so that is our failover procedure. So we'll now do our fail back, which is pretty much the same process but in reverse. So the process will be, we're going to delete our UDLR control VM. Now we can only do that via a REST API call. Then we'll delete our 3 controllers. Then we will demote our primary back to transit and then join it back to our primary back in our old Site A and be pretty much back to where we started. Okay, so first thing we want to do is delete our UDLR control VM. So let's go and have a look at it. So it's that fellow there. Now the only way, supported way of deleting that is via a REST API. Obviously we could just right click delete the VM here, but that would leave some config residue in NSX Manager. So let's go and have a look at it. So this is the entry that appears under the logical router appliances section. Okay, so again, what we could possibly try and delete it there, let's say the recommended and supported method is via the REST API, so we shall do that. So this is now on our our NSX Manager in Site B. So let's fire up our REST client. So let's get our edges from Site B. So I have a REST call there. So get edges from Site B. And the one we're looking for is the UDLR. So not RESG, because that's our north-south. It'll be the long hexadecimal value. There's our load balancer. And it'll be this one, UDLR. So the value we want is the object ID. This fella here. That's 020. So if you want to validate that, you can always pop back to your network and security and just compare it to the value at the end of this as a little double check. So 020, so that's definitely the right one. It's a bit easier when you've only looked at one. You can imagine if you had a dozen or so UDLRs as you would likely to have in a production environment. Right, so let's go back to our SOAP client. In fact, let's have a look here and we'll see it delete. So it'll be that fellow there that should go. So let's see if I can have them both on screen at the same time. So again, a nice way I sort of tend to validate it is I'll put the edge ID at the end of that REST call, do another get, just to make sure I pull the actual config for the exact edge I'm working with. So you can check the name, I should say UDLR 01. There we go, UDLR 01, so that is definitely the one. And then we can flip that get to a delete. And this will delete the virtual appliance. If you had two in H8, it will delete them both. So we should see that fella there vanish. Okay, delete virtual machine is occurring down below. I think that is, yep, so it looks like that's deleted, so a little refresh, no doubt we'll get rid of that. Okay, so that's gone. So that's our UDLR control VM gone. So next thing we're going to do is just delete these three controllers. So again, on our little watch it tab there, we'll start seeing our site B NSX constructs going red, and our A's will gradually come back green. Again, it will just take a little bit of time because it's still trying to refresh the original primary. Just may need to relog into the client. I think my web client has stalled a bit. So what I'm expecting to see here is our primary NSX Manager currently in Site B and our 3 controller nodes associated with the manager in Site B. Okay, so I'm not sure where those controllers have gone. Let me just try looking into the other site. This should be a fairly quick fail back because we're doing a fail back pretty much straight after our failover. We'll just get away with powering back up the 3 controllers and the UTLR control VM in Site A and our load balancer. If this was running in any extended period, we'd probably delete those elements in A and recreate them fresh as and when we did do the failback. Let's just have a look here. So it won't see the primary NSX Manager because that's turned off, but it should see the one in Site 2, which it does. Let's see if it's seeing our controllers. Okay, so yes it is. Not quite sure why I'm not seeing them on this one. Just do a refresh. Just may need a full log out and log back in again maybe. Okay, let me just log that out. Okay, but say we are seeing it from our other linked mode vCenter. So we'll just delete them, and again I tend to do things in the reverse order, so we'll delete controller 3 first. So this will not only delete them out of NSX Manager, it will also delete them out of the inventory. It will delete the controller VM. And it does remove them quicker than it creates them, so it won't be sort of a 5 minutes wait for each one, which will probably be a minute or so. So again, you need to delete the UDLR control VM and the controllers while that's still a primary. If you try and do it after you've demoted this, you'll get an error saying invalid on a non-primary NSX Manager for the UDLR. So you can see there our red dots are starting to reappear on the bottom, so that's one of our controllers gone. So again, unfortunately you can't delete these all simultaneously, you have to do it sequentially. So again, just like we saw when we were deploying the cluster, as each member is removed, the remaining nodes will reform a new cluster and reform their majority. So again, just for clarity, I've left the Site A constructs, the controllers and NSX managers, powered down for the moment. I could have powered them up, in which case I'd just see more controllers here. Another reason I tend to prefix the controllers with the site, so I know exactly if I did see a big long list of controllers, which ones were the original Site A controllers and which ones were the temporary Site B controllers. So you can see we started our fail back probably about just over the hour mark. So about an hour to do the full failover. You can hear some hammering in the background. My neighbour across the road is having his roof replaced, in case you're wondering. Okay, so that's controller 3 gone, let's delete controller 2. So you can see down there in the recent tasks as the VMs are deleted. Okay, just before I delete that last controller, just to save a little bit of time, I will start to power up our NSX elements in Site A. Which we are 3 controllers and our NSX Manager. and our load balancer, which was our primary load balancer in site A, which is our load balancer here. So that was our VIP for our web services. So if we're powering that on, we will have to power off our load balancer in Lano in site B, which is that one there. So we don't want those two identical VIPs clashing with each other across sites. Okay, so my NSX controllers in site A are gradually coming up. Obviously our web VIP is down currently because that was our load balancer across the site B. Our NSX Manager should be up fairly shortly. Let's go and delete our last controller. Okay, not quite ready yet. Okay, there's our last controller, so we'll delete that. And this one we have to tick this little box that says forcefully delete and understand that deleting our last controller essentially renders our centralized control plane inoperative. But it won't be for long. So again, all the hosts and the data plane will remain their last known state. So the controllers would have pre-programmed them with the last known routing information. So again, if you've got a nice resiliently designed NSX network, this shouldn't cause any traffic disruption. Okay, so NSX Manager is not quite up yet. Our 3 controllers are back up. Okay, so that last controller is gone. Okay, let's see, our NSX Manager is still red. Let's go and have a little look what's the situation there. See if we can give it a... In fact, we won't be able to ping it because that's essentially what that's doing. Let's go and have a look. Panic. That doesn't look good. Let's just restart that. were seeing. Okay, so that looks a bit better. So we are green on NSX Manager. Let's see what our network and security is looking like. I may have to log out and log back in. In fact, that's what I think I'll do, because I'd expect to now see two primaries. Taking a little while to log in. Not sure it's the lag on my VPN, but give it a refresh. Okay, so I'm just seeing the one primary NSX Manager there, which is the one in Site B. Let's have a go back into Site A now. That seemed to log in a bit quicker, which would indicate hopefully it hasn't had to wait too long to find an inventory. Okay, so 150 is our original primary in site A. Okay, so that's what I'd expect to see. 2 primaries at this stage. We should see our original 3 controllers. Okay, so that synchronization issue there is because I think that primary NSX Manager is also configured with a secondary, which happens to be also listed here as a primary. That makes sense. So I think if we remove the secondary from that original primary, remove secondary NSX Manager, because we're going to add it back in. So again, there are 3 original controllers. Sure, that one sound disconnected is probably just needing a refresh. Okay, so yep, so that removing that secondary has cleared that sync issue. So what we now want to do is go to our NSX Manager in site B, which is our 153 one here. We now want to remove primary role. Yep, they still haven't finished that roof out there. Can probably be a wee while yet. Okay, so that's now put our site B NSX Manager into transit. So what I should now be able to do is go to our primary, add secondary. It automatically finds the transit it's in the inventory with, so we'll just put in our admin account. So we should get our thumbprint back. Okay, so that now should join the primary as a secondary and then retrieve a shadow copy of all 3 of those controllers. Okay, so something's not right there. Just do a refresh. Okay, again I'll sort that disconnected controller out in a sec. If it's nothing obvious, it's probably easier just to delete that controller and redeploy it, but we'll have a look in a minute. let's just make sure we can ping that secondary NSX Manager. Yep, so that looks okay. Just do an update of the controller state, which basically just pushes the settings down again, just to let's just have a quick look at what we're seeing from the other NSX Manager. Okay, let me just log out and log back into this client. Oh, I think our VIP is up for our load balancer. Yep. So yeah, so now back to all our green lights and our 3 red dots for our deleted controllers in Site B. So let's try and do just the last thing here. So this should join our Site B NSX Manager back as the secondary. We should see 3 shadowed controllers be created, which will be pointing at NSX Manager B. But effectively those shadow controllers are just those same three controllers. Okay, so there they are. They should go connected very shortly. So as you can see there, they're managing the secondary NSX Manager .153, but they're managed by the primary. And you'll see those IP addresses 147, 148, 149, identical to the 3 real controllers. So again, they're just pointers. So again, sometimes you need to give it a little poke. Let's go to a refresh. Okay, so we're all back to connected again, and with all this failing over and failing back, what I tend to do is just do a quick update controller state, just to push all those settings and universal objects back down to the controllers again, just to make sure we're all fully in sync. Okay, always good to check our dashboards, make sure we're all back to green squares. Okay, that looks good. Check our secondary. Okay, then just before we just do a confirmation of all our data plane, let's just make sure we're getting a consistent UI through both vCenters. So again, I'm just going to log out our client in vCenter A just for a complete refresh. So what I'm going to expect to see here is a nice consistent view with our vCenter and NSX Manager in Site B. Okay, so first thing I always just double check is that we're seeing our enhanced link mode, we're seeing both sites, which we are. And then I'll just double check our network and security, make sure we're seeing both NSX managers. Which we are, which is good. So both VCSAs are consistent. Our web VIP is now up, so that should now be back to providing load balancing to both sites. So if we go back to our load balancer up here, this should be back up. And we should be back to flipping between site A and site B. Let's do a couple of refreshes. That's site A. Site B. Okay, that looks back up. So the fact that our web server is load balancing from my jump box here, which is actually going through the virtual environment. Just have a look on our map. So my jump box is northbound of all these edges, so actually coming through 160. We've got a backup path going via 161, going through the UDLR, going through into the web logical switch, hitting our load balancer .100, and that load balancer then has a member in site A and a member over in site B, and it's just doing a round robin load balancing algorithm, just throwing requests either side. So how long has that taken? Oh, just under 2 hours. So if you're still with me, thank you very much for sticking with it. Hopefully you've learned something along the way and are a little bit more confident if you ever have to do this in anger. So until the next time, thanks again, and I'll see you in the next video. Take care. Bye bye.